Welcome to Math Master. This is SARITHA. Today our topic is Altitude-Orthocentre. So we'll first know what is an altitude and we'll later discuss about orthocentre. So what is an altitude first? See, you take one triangle. So this is a triangle. In this, these three are vertices of a triangle. See, A, B, C. These three are vertices of a triangle. So, if you draw a perpendicular through vertex, so this is the vertex, we are drawing a perpendicular through this vertex to opposite side. So, this is the perpendicular line we are drawing through the vertex onto the opposite side. So, this we call it as an altitude. This is an altitude. In other words, we call it as height. Okay. In other words, what we call it as? It is also called as height. So, this is what we call it as foot of the perpendicular. So, this is the perpendicular we are drawing onto the opposite side and this is the foot of the perpendicular. So, does this altitude need to divide the opposite side into two equal parts? Need not be, because in the case of centroid, what we have seen while drawing the median, that median should divide the opposite side into two equal parts. But in the case of altitude, this altitude need not divide the opposite side into two equal parts. So these two parts may be equal, may not be equal. Okay. So this is an altitude. So how many altitudes are possible in a triangle? See, as there are three vertices in a triangle, how many altitudes are possible? From each vertex, we can draw one altitude, right? So that is why there are three altitudes. There are three altitudes are possible in a triangle. So, okay. Next, so what is an orthocenter? Orthocenter is nothing but, so in the triangle, if you draw all the three altitudes, see, I am drawing one more altitude through vertex B. So this is foot of the perpendicular E. See, and I am also drawing one more perpendicular. See, this is F, CF altitude. So I have drawn all the three altitudes in a triangle. What happened? So these three altitudes are concurrent at one point. Yes, this is the concurrency of the all the three altitudes. So this point we call it as an orthocenter. So what is nothing but orthocenter is nothing but a concurrency of altitudes. So if you draw altitudes in a triangle, so the concurrency of those altitudes we call it as an orthocenter. So orthocenter is always represented by either O or you can also represent with H. Okay. So you can represent either with O or with H. Okay. So this is what an orthocenter. Now we have to know some properties about orthocenter. So in the case of centroid, what we have seen, so the centroid is you always interior of a triangle. So whether you consider which type of triangle it may be, so the centroid is always interior point. But in the case of orthocenter, what happens? So this orthocenter depends on the type of triangle. If you consider an acute angle triangle, this orthocenter is always inside the triangle. See, this is an acute angle triangle. So all the three angles are acute angles. So this is an acute angle triangle. So what is the where is the orthocenter? So the location of the orthocenter is nothing but interior of the triangle. So you consider an obtuse angle triangle. See, this is an obtuse angle triangle. So according to the definition of altitudes, through the vertex, we have to draw a perpendicular on to the opposite side. So for this vertex, what is the opposite side? BC, right? So, but if you draw a perpendicular, so it will be like this, isn't it? Yes. But for in order to be perpendicular to the opposite side, what we have to do? So we have to extend this side to this side, right? So here It is exactly perpendicular to the side BC, isn't it? Okay, this is fine. What about the vertex C? We have to draw one more perpendicular, right? So for this, opposite side to BC is what? AB is the opposite side to BC. So for what? So for that we have to extend the side AB. Okay. Now you draw a perpendicular to this. Okay. So this is the perpendicular. And what about the vertex B? So for this is the perpendicular. So but we need a concurrency of these three altitudes, right? So for that I am extending this. Okay. See. So I am extending this as well as I am extending this. See. I am also extending this. So here these three altitudes are concurrent. So what we have seen? So this is an orthocenter because it is the concurrency of all the three altitudes. But we have considered an obtuse angle triangle. That is why the orthocenter is lies outside the triangle. So in the case of centroid, we have seen which type of triangle you take. The centroid is always interior of a triangle. But in the case of orthocenter, if you consider an acute angle triangle, what happens? The orthocenter is always interior of a triangle. In the case of obtuse angle triangle, what happens? The orthocenter is lying on outside of the triangle. So you consider one more case. So if you consider right angle triangle, see this is a this is a right angle triangle. So these are the vertices of a triangle. So this is 90 degrees, right? So what is an altitude definition? See, this is the vertex A. So through this vertex, we are drawing one perpendicular to opposite side. This is nothing but this only. Yes. And from this vertex, we are drawing perpendicular on to the opposite side. This is this only. And from this vertex, we are drawing a perpendicular to the opposite side. So where is the concurrency of these all the three altitudes? See here at the point of B only, right? So that is why when you consider a right angle triangle, what happens? So the concurrency of the altitudes is always at the vertex, which is at the right angle. See, this is the vertex B. Here the angle is 90 degrees. It is right angle. Here always the orthocenter lies on the triangle in the case of right angle triangle. So orthocenter lies on the triangle and exactly at the vertex which is right angled. So this is what in the case of orthocenter, by depending on the type of triangle we are considering. So the orthocenter lies once interior, once exterior, once on the triangle. So okay, so these are the three properties. So what the first property? So the always if you consider acute angle triangle, orthocenter is always inside the triangle. So when you consider an obtuse angle triangle, the orthocenter is always exterior of a triangle. So when you consider a right angle triangle, the orthocenter is always lies on the triangle at the vertex at the right angle. Okay. So these are the three cases we have seen in the case of orthocenter. See, these ABC is the triangle, right? So this is the orthocenter O. These A, B, C, O. So these 4 points, these three vertices as well as one orthocenter called these 4 points are the orthocentric points. These 4 points are the orthocentric points. See, so we have one property, that is if you consider these 4 points, the triangle formed by any of the 3 points. You consider any 3 points in these 4 points. So you consider A, B, O. Okay, A, B, O. So what happens? This is a triangle formed by A, B, O. So this is what? Where is the orthocenter of this triangle ABO? Which is outside of the triangle, that is at the C. Okay, you observe the speciality of these 4 points. You consider any 3 points of these 4 points, the triangle formed by those 3 points. For that, orthocenter is always the fourth point. See, if you consider triangle ABO, what happens? For this, orthocenter is at the C. Okay. If you consider triangle BCO, what happens? Orthocenter for this BCO is the fourth point, right? So which is nothing but A. And for triangle ACO, what happens? The orthocenter is nothing but B. So in this way, the triangle formed by any of these 3 points, the orthocenter of that triangle is always be the fourth point. This point is very important while solving the theoretical questions. So there he may give that the 4 points, these are the orthocentric points. So that time you should identify, okay, these four are the orthocentric point. So in the case of orthocentric points, what happens? Always the triangle formed by any 3 points, the fourth point will be the orthocenter of the triangle. So this you need to remember, and then you can easily solve the questions. Okay. So next, now we have to see one relation. See, this is the vertical angle we are considering. Okay, this is a vertical angle, and this is the angle subtended by the opposite side. So this is the opposite side to the vertical angle, right? So this is the opposite side, the angle subtended by this opposite side at the orthocenter. So this is the orthocenter, and this is the angle subtended by this side at the orthocenter. So these two angles are always supplementary to each other. This is the relation between the vertical angle and the angle subtended by the opposite side at the orthocenter. So this relation is very important while solving the questions related to the solving for the angles. Okay. So what is the relation? So this is the vertical angle, angle A, plus the angle formed by the opposite side at the orthic center, which is nothing but angle BOC, which is always supplementary, nothing but the sum of these two angles is always equal to 180 degrees. So this is the relation you have to remember. Okay. Next we'll see what is an orthic triangle. Orthic triangle. Okay, so this is a triangle ABC, and these three D, E, F are feet of the altitudes, right? See, this is the foot of the altitude through A, and this is the foot of the altitude through B. This is the foot of the altitude through C. So these three are feet of the altitudes. So the triangle formed by, this is the triangle formed by, this is the triangle formed by feet of the altitudes. We call this triangle as Arctic triangle. So what we call? This is a Arctic triangle. Arctic triangle. Okay. So what is the speciality of this Arctic triangle? So you consider whatever the triangle which is inscribed in a triangle. So this is a triangle, and the triangle inscribed inside a triangle. Okay, inside a given triangle. So this is one type of triangle. So there may be other type of triangles also inscribed in a triangle. Among all these triangles, this orthic triangle has a least perimeter. So that is the speciality of orthic triangle. Okay. he gives a relation that AB square plus BC square which is equal to AC square. So if he asks where is the orthocenter of this triangle, if he gives this statement and he will ask for the orthocenter of this triangle. So by looking at this relation, what we will know? We will know that this is a right angle triangle, right? So this is the hypotenuse AC. So we know very well that for the right angle triangle, where is the orthocenter? Orthocenter is always on the triangle and at the vertex at the right angle, right? So where is the vertex at the right angle? Which is always opposite to the hypotenuse, right? So vertex which is opposite to the hypotenuse, where the that is the place where right angle lies. Okay, so this is the AC is the hypotenuse. So the vertex opposite to AC is what? B. So B is the orthocentric point of this triangle. Okay, by looking at this statement only, we are finalizing that orthocenter is B only. So in this way, you can easily identify where is the orthocenter of the triangle. Okay, thank you.